Hello students, in today's video we are going to discuss about benzene diazonium chloride. That is a very important topic from amines. First of all, what is a general formula of benzene diazonium chloride? That is R N2 plus X minus. This R can be any aryl group like benzene, and this X minus can be halides or HSO4 minus, hydrogen sulfate, BF4 minus, fluoroborate. And then generally we will prepare this benzene diazonium chloride from the primary amine called aniline. This aniline, when reacts with a reagent like sodium nitrate along with HCl, hydrochloric acid, and the entire condition should be around 0 degrees Celsius to 5 degrees Celsius, which means 273 Kelvin to 278 Kelvin. Like this ice cold condition we can able to prepare benzene diazonium chloride. And then what is the use of the sodium nitrate and HCl? The sodium nitrate and HCl combine to give very important reagent that is called a nitrous acid. This nitrous acid is stable only at this temperature, that is 0 to 5 degrees Celsius, and moreover the benzene diazonium chloride which formed also stable at 0 to 5 degrees Celsius. If we are increasing the temperature, like if we bring it to the room temperature like 25 degrees Celsius, the benzene diazonium chloride will decompose. So here this N2 plus benzene diazonium, diazo means two nitrogens are there, so diazo, IUM, if anything ends with IUM that will be positively charged, so diazonium. And then whatever the acid if I am using, the same anion I will get. Yes, suppose if I am using sulfuric acid, aniline, here under this ice cold condition 0 to 5 degree Celsius, when it is treated with NaNO2 plus H2SO4, if suppose, means we will get the product N2 plus HSO4 minus bisulfate, benzene diazonium bisulfate, sorry. And if I am using nitric acid, I will get benzene diazonium nitrate. And if I am using fluoroboric acid, NaNO2 plus HBF4, I will get N2 plus BF4 minus. So like this we can able to prepare diazonium salt. Here the anion doesn't matter, only the benzene diazonium is very important. So primary aromatic amines, when treated with the nitrous acid, we can able to prepare benzene diazonium salt, and it is stable only at 0 to 5 degrees Celsius. And this benzene diazonium chloride is stable. Benzene why it is stable? Can you know the reason? Because of resonance factor. Benzene diazonium salts are stabilized through resonance. So here it's a triple bond. Here one nitrogen with the lone pair, another one is carrying the positive charge. So how can we draw the resonance? Here this positive group always a electron withdrawing group. So the electron density move towards the positive nitrogen and it will delocalize like this. In the next case, positive charge will be there because the electron shifted between carbon and nitrogen. Now also it is positively charged, but here it will become double bond with two lone pairs and negative charge. Like that it will delocalize. Due to this delocalization, the compound gets the stability. Benzene diazonium chloride or any benzene diazonium salts are stable due to this resonance factor. Resonance will increase the stability of the organic compound. Not only organic compound, in anywhere if resonance stabilization is there, the molecule will be considered as more stable than the normal molecule. So as we already discussed, benzene diazonium chloride gets its stability through the resonance factor. But alkyl diazonium chlorides doesn't have such kind of resonance, so that it is highly unstable and decomposed. You can able to see how the pi electrons delocalized, and this N2 plus group will act as electron withdrawing group. So it will take electron from the ring. How can we prepare this benzene diazonium chloride? This is what already we discussed. So this reaction is called diazotization reaction. Naming reaction, diazotization. Reaction to prepare benzene diazonium salt. Okay. So here, apart from this benzene diazonium chloride, we can able to prepare some NaCl and water as well. Okay, so we prepared the benzene diazonium chloride. What are the physical property of it? How it looks? Physical property of benzene diazonium chloride, that is, it is a colorless crystalline solid, and it is soluble in water. So once it's prepared, it will be in the solution form, and also it is stable in cold condition. Cold condition means the same 0 to 5 degree, okay, not 25 degree, and it can easily decompose in the dry state. Dry state means the normal room temperature. Dry state it will decompose, right? So the benzene diazonium fluoroborate, except the fluoroborate, that is C6H5N2 plus BF4 minus alone, water insoluble. Remaining all whatever we have discussed, it is soluble, and another condition, it is stable at room temperature. That is the exceptional part we have to learn. All the benzene diazonium chloride, benzene diazonium hydrogen sulfide, even bromides are unstable at room temperature and it will decompose. But benzene diazonium fluoroborate is stable at room temperature and it is insoluble in water. That is the case, it is different from others. Okay, so this is about how we can able to prepare benzene diazonium chloride. Now we are moving to how to convert this benzene diazonium into different compounds. So this bromobenzene can be prepared from benzene diazonium chloride, and similar way we can able to prepare cyanobenzene in the same method. For this we have to take Cu2Cn twice, or in some place it will be given as CuCN. That is, copper should be in +1 state. That is very important, and as a result we will get what? Cyanobenzene. You know very well, cyanobenzene on hydrolysis we can able to prepare benzoic acid as well. So this reaction is very important naming reaction, that is called Sand-Meyer's reaction. You have studied this in haloarenes preparation as well. In Sandmeyer's reaction, the main reagent is copper plus 1 kind of salts. Instead of using a copper based reagent, if I am using copper powder along with the halogen acid, that is called a Gattermann reaction. Benzene, diazonium salt, when it is treated with copper powder along with hydrochloric acid, same I will get chlorobenzene along with N2, and same way I can able to prepare bromobenzene. So both the methods reagents are entirely different. Right? Here I have prepared chlorobenzene, here I have prepared bromobenzene, but the reagent and the condition is different. Here we can use copper powder in the presence of halo acid. What is the name of the reaction? Very, very important. That is Gattermann reaction. So in this method, we can able to prepare halobenzene, that is aryl halide. When we compare Sandmeyer and Gattermann, which is the best method in this sense, Sandmeyer will be considered as better than Gattermann reaction. So the next one we are going to discuss, how can I prepare iodobenzene? Because we have prepared chloro and bromo, how can we prepare iodobenzene? For that we need potassium iodide. Right? Iodine is not easily introduced into benzene ring, but using benzene diazonium salt solution we can able to prepare. So here I have to use potassium iodide. So I minus will displace the diazonium group. So here I will get iodobenzene. In all case, nitrogen will be evolved as gas. Right? And how can I prepare fluorobenzene using this? That is another very, very important reaction. With this, we have to treat a reagent called fluoroboric acid, HbF4, that is called fluoroboric acid. So what will be the product we will get? Benzene diazonium fluoroborate N2 plus BF4 minus. What is the nature of fluoroborate? They are stable at room temperature. Unlike other benzene diazonium salt, it is not soluble in water. When we heat this, what happens? We can get fluorobenzene along with N2 gas. So using this method we can able to prepare fluorobenzene, iodobenzene, chlorobenzene, bromobenzene. Okay, in the reactions involving displacement of nitrogen, next we are going to discuss replacement by hydrogen. So few reducing agents we can use. For example, hypophosphorus acid, that is H3PO2, also called as phosphenic acid. When it is treated with benzene diazonium salt, it will act as a reducing agent and it will oxidize itself to a phosphorus acid. Right? So it's a kind of redox reaction. So benzene diazonium salt on reduction with hypophosphorus acid gives benzene as a main product. And along with that, this hypophosphorus acid itself get oxidized to phosphorus acid, H3PO3, and N2 gas evolved. Along with that we will get HCl. Right? So it's a kind of reduction reaction. In similar way we can use ethanol as well. the benzene diazonium chloride, when we treat ethanol, the same kind of reactions happen. As a result, we will get benzene as one of the product. Along with that, this ethanol itself get oxidized into ethanol, right? And we will get N2 and HCl as the products. Clear? So this reactions involves replacement or displacement by hydrogen atom. Next, how can we displace the diazonium group by hydroxyl group? We can displace the diazonium group with the hydroxyl group. For that, we have to treat it with just water. Under cold condition, it will not react with water. But if we are increasing the temperature up to 283 Kelvin, which means around 10 degrees Celsius itself, which means we are just raising the temperature. The diazonium chloride, it is stable at 0 to 5 degree. I am just increasing the temperature, so it will not stable at this temperature. So this diazonium decomposes and the hydroxyl group displays that. We will get phenol as our product. Phenol can be prepared from benzene diazonium chloride. It's one of the preparation method for phenol. And how can we replace this diazonium with nitro group? That is another important case. For that, first we have to convert it into water insoluble form. For water insoluble form, we can convert it into fluoroborate. For that, I need to use fluoroboric acid. What happened? It will be converted into benzene diazonium fluoroborate. Okay. With this, if we are heating, we can get fluorobenzene, but the case is different. We are going to treat it with sodium nitrate. In the presence of copper powder, we have to heat it. So what happened here? This fluoroborate group and the N2, it's decomposed and we are getting NO2, nitrobenzene. We will get sodium fluoroborate. So if you see this, we can able to prepare nitrobenzene as well. So these are all the reactions which involves the displacement of nitrogen from diazo groups. We can able to displace with the halogens, we can able to displace with the cyanide, we can able to displace with hydrogen, hydroxyl and nitro groups. So this is our product. You can able to see the OH is a main group, functional group. So it will activate the benzene ring towards electrophilic substitution at ortho and para place. Due to the steric factor, para product will be the major product, right? Along with that, we will get Cl minus and H2. So this compound is called, except this OH, if we are calling it as azobenzene, the OH is attached to the fourth place, that is called para-hydroxy azobenzene. It is a dye with the orange color. We call it as orange dye. Similar way, benzene diazonium chloride can undergo coupling reaction with aniline as well. The main thing we have to observe here, we need to keep it in the basic medium. Phenols are acidic, we have to keep it in the basic medium for the better result. The next case, how it will treat it with the aniline. I am taking benzene diazonium chloride. I am going to take aniline. Aniline also ortho-para director, that NH2 attached to the benzene ring. The substitution happens at para place. One thing, amines are basic, no? So we have to keep it in the acidic medium. Instead of that H plus, this N2 plus will attack. In the point of aniline and phenol, it is a electrophilic substitution reaction. So now this NH2 group is attached to the para place of azobenzene. It's called para amino azobenzene. It's a yellow dye. Right? So this kind of reactions are called coupling reaction. It's an example of electrophilic substitution reaction which will act as electrophile. The diazonium N2 plus along with the benzene is an electrophile. It will attack ortho as well as para place, but the major product will be a para one. It gives a colored compound, so we call it as a dye, and it's one of the reactions happen in the dye test as well. The importance of benzene diazonium chloride. We can prepare a lot of compounds like phenol, benzene, nitrobenzene, because the N2 group can be displaced by fluorochlorobromoiodocyano. In fact, the fluorobenzene cannot be prepared. This fluorobenzene cannot be prepared from direct halogenation, but we can able to prepare from diazonium salt. That is a main advantage of this. Cyano group cannot be introduced by nucleophilic substitution of chlorine from chlorobenzene to cyano, but in this method we can easily introduce a cyano group, right? So this benzene diazonium chloride is considered as very important chemical to prepare a lot of compounds, right? I hope you understand whatever the reactions we have discussed in this video. Follow for more videos. In the upcoming videos we can able to do a lot of questions regarding this. Thank you for watching.